talking about my Physics 2 Lab 1, which is charge tapes. So, a brief introduction of concepts. I will be observing how charged objects interact with each other and its surroundings in a natural setting. Specifically, I will be noting the difference between the interaction of two charged objects versus the interaction of one charged object and one neutral object. Now, I'll use the known gravitational force to help calculate the electric force, and I'll use the charge of the object to calculate the ratio of the free charge of the atoms. So, a brief overview of the lab procedure. I observed the interaction between the two charged pieces of U-tape, and I observed the interaction between a charged piece of tape and a charged plastic pen. I estimated the amount of excess charge of a tape using the floating distance, as shown in the diagram here. And I used real-life observations and the mathematical concepts we learned to calculate the charge of the objects. So, overview of the results. The two charged U-tapes repelled each other because they are both of the same charge, because they were both made in an identical manner. And then the U-tape was to be positive charged because it attracted to a charged plastic pen, which we know to be negatively charged. And since the U-tape is energy deficient, it interacts with a neutral object such as a textbook or my hands. And when the second U-tape floats, the electric force is equal to the gravitational force in that moment. So some quantitative data I gathered during the experiments and measurements include the length of the tape, which is 0.2 meters, the weight of the tape, which was estimated to be 0.0002 grams or kilograms, and then the distance between the two U-tapes was to be 1.6 centimeters when it was floating. And some constants I use is K, which is 9 to the 10 to the ninth power, and then the charge of one electron. And then the calculations. I first calculated the gravitational force on the tape, which was just mg, so the mass of the tape times the acceleration constant due to gravity, and the force was 0.00196 newtons. And then the magnitude of the electric force at that moment when it's floating is equal to the gravitational force, so it is also 0.00196 newtons. And the charge of the tape, I used the equation that was provided in the lab for us, and when I calculated for the Q value, I got Q is equal to 5.9 times 10 to the negative 8 coulombs. And then to calculate the number of electrons in the tape, I first divided the charge of the tape over the charge of the electron, and I did that by doing the found charge in the previous calculation over the known charge constant of charge of an electron, and I got 3.689 times 10 to the negative 10 to the 11th. And then for the number of atoms in the tape, I got area of the atom, which was provided to us in the lab report, and then divided by the area of the tape. So I got their number of atoms in the tape was 4 times 10 to the 17th. And to find the number of electrons per tape in the atom, I divided the number of electrons over the number of atoms, and then I got 9.22 times 10 to the negative 7th. And after doing this lab, there were some reflection questions. So the electrons had a positive charge, and the protons had a negative charge. The U-tapes that we would observe would have to have a negative charge. This is because the U-tapes that were charged, they became charged because electrons were stripped away. Thus, if positive electrons were stripped away from the neutral object, the U-tapes would become negatively charged. So then it would interact, repel against the charged plastic tape versus it repelled. And then why is it important to handle the charged tapes as little as possible? With each interaction, there's a transfer of electrons from one object to another, so the charge might not be strong as we want it to be. And for the coding section of the lab, I basically took the constants that we have, made two spheres that represented tape 1 and tape 2. So using this, we assumed and treated each tape as a point charge, and where the charges are centered at the center of the tape. And we also ignored air resistance in our formula. And then I used the functions from the previous lab 0 and a new one that called charge to calculate the charge and the electric field of the tape. And then I was able to calculate the force of the gravity and the electric force on tape, which is just equal but opposite signs. And the arrows show the force of gravity and the electric force on tape 2, which is the floating tape.